Students, welcome to the session of chemical reaction. In the last session, we discussed about chemical reaction. What is it? Okay, now what is a chemical reaction? As we have discussed, it is a change in the chemical composition of a substance. Right, now in a chemical reaction, there are two entities participating. They are the reactants and the products. Right, now a chemical change takes place by the breakdown of bonds in the reactant molecules and the formation of new bonds. Right, this formation of new bonds results in the formation of a product which has different chemical properties than the reactants. Okay, now let's take an example, that is burning of magnesium ribbon. Now when magnesium ribbon is heated, what happens that magnesium reacts with oxygen or burns in air and it forms what? Magnesium oxide. Now this magnesium oxide is a white powder. Right? Now this magnesium oxide is altogether a new product. It has properties different from magnesium as well as oxygen. Fine. Now this magnesium burning in oxygen giving magnesium oxide is a chemical change, and its word equation is represented like this: magnesium plus oxygen on heating gives magnesium oxide. Fine. So this is a chemical change or a chemical reaction. Now students, every chemical reaction is accompanied with some observable features. Now these observable features are known as characteristics of chemical reaction. Now just tell me, what do you mean by these observable features? Observable features means like in certain reactions some gas is evolved, in certain reactions there is a formation of a precipitate, in some reactions there is a color change, and in some reaction there is a change in state of matter. Now as I've already told you that the chemical change takes place on the molecular level. So every time to check whether the reaction has taken place or not, you can't go to the molecular level. Fine. So what is done is that these features are observed, and these features are known as characteristics of chemical reaction. Fine. Now first among these characteristics is evolution of a gas. Means when two substances are reacting, a gas is evolved there. Fine. For example, when zinc is treated with dilute sulfuric acid, hydrogen gas is evolved. Now how could you tell whether a gas is evolved or not? When a gas is evolved, there are bubbles formed in the test tube. Okay, so when you put on dilute sulfuric acid to a test tube containing zinc, what will happen? After a few seconds, there will be bubbles formed in the test tube. So that indicates that the chemical reaction between zinc and dilute sulfuric acid has taken place. Okay, now let's take another example, that is the reaction of sodium carbonate with dilute hydrochloric acid. Now, I know students, these are the new terms for you, but we'll soon be discussing its chemical formula and we'll be writing its equation. Right? So, when this reaction between sodium carbonate and dilute hydrochloric acid takes place, there is evolution of carbon dioxide gas. Again, it is an observable feature. As soon as you are finding bubbles in the test tube, what you can conclude is that the reaction has been taken place. Got my point? Now here I am using a new term, that is dilute. Now what do you mean by this dilute? There are two terms, dilute and concentrated. Concentrated means that is a pure sulfuric acid which has a concentration of 95% volume by volume. That is 95 ml of sulfuric acid in 100 ml solution. Got my point? So in that solution, how much is sulfuric acid? 95 ml. And what about water? It is 5 ml. Now that is concentrated. We cannot use it every time, right? So it is diluted. Well, how it will be diluted? By adding water to it. So your dilute sulfuric acid will have concentration like 25% V by V. What do you mean by this? That 25 ml of sulfuric acid is present in 100 ml of solution, right? So that 100 ml will contain 25 ml sulfuric acid and rest of the 75% will be water. Right? So dilute and concentrated is used in equations just to tell what concentration of particular solution is used. Got my point? So this is one of the observable change. Now another change which we observe when a chemical reaction takes place is formation of a precipitate. Now students, do you know what is a precipitate? You must have added soil into water. What happens? That soil settles to the bottom of the test tube. Okay. Now if you go on adding sugar to say 10 ml of water, what will happen? To a point the sugar will be dissolved and after that it will be settled at the base of your glass. Fine? Now a precipitate can be defined as a solid product which separates from solution during chemical reaction, right? So there are certain reactions in which these precipitates are formed. Is it clear to you? Precipitate, a solid substance separating from the solution. Got my point? So in a test tube, what you will get is the liquid part and below that at the bottom there will be a solid substance deposited. Now that solid part is called as precipitate. I'll elaborate it with few examples. Say, if I'm adding potassium iodide, right, to lead nitrate, what is formed here is lead iodide. Got my point? Now this lead iodide gives the yellow color. It means in your test tube, what are you having? You are having lead nitrate. To this, you are adding potassium iodide. Right? There will be a chemical reaction. Fine? The bonds between potassium and iodide will be broken, as well as the bond between lead and nitrate would be broken, and what will be formed is, what will be formed students? A new bond will be formed and that will be of potassium and iodide. So I can write it here like potassium iodide right? There is a bond between these two. And lead nitrate. Right? There is a bond between lead and nitrate. So what is happening? This bond, this particular bond is being cleaved. And here this bond is being cleaved. And what is forming is, children, there is a new bond formed between lead and iodide. Fine? Now what I'll get is lead iodide. Now this reaction is giving me lead iodide. Got my point? So this lead iodide precipitates in the test tube as yellow PPT. As soon as you are finding this yellow PPT, what can you conclude? That the reaction between potassium iodide and lead nitrate has been done. Right? Now, let's take another example. Say sulfuric acid. Okay? The reaction between sulfuric acid. Right? What is the formula of sulfuric acid? You have not done it, so I'll not tell you the formula right now. Once I'll tell you how to write the formulas, then we'll discuss few formulas. Right? Here you just remember the name of the reactant. Now this sulfuric acid, when it is treated with barium chloride, right? Now what is the new product formed here, students? It is barium sulfate. Okay, now this barium sulfate, how it precipitates, how it will be seen that barium sulfate has been formed? It gets precipitated or settled at the bottom of the test tube. Right? So again, as you see that precipitate is formed, it can be concluded that the reaction between sulfuric acid and barium chloride has taken place. Okay? Now there are certain other features also. Like when you mix two reactants, there is change in color. Okay? That is the color of the solution changes. Right? Now here I have taken an example of citric acid and potassium permanganate. Now the chemical reaction between citric acid and purple colored potassium permanganate solution is characterized by change in color from purple to colorless. Okay, now this potassium permanganate is a solution which has got a purple color. You must have seen this in your laboratories, or if not, you can just go and check out about this. Right? So this potassium permanganate is purple colored. Now students, just tell me where you'll find the citric acid. Just remember your mom's kitchen. You'll get it somewhere there. It is in the citrus fruits, or it is in lemon. Lemon is the best source of citric acid, right? Now, if I'll add that citric acid to this potassium permanganate, what happens is that the color of potassium permanganate changes from purple to colorless. That is, we can write here purple. To this we added what? Citric acid. Then what happened to the color, children? This became colorless. Fine. So it is very easy to say that the reaction has been done. The reaction has been completed. Okay. Now let's take another example. That is of the reaction between sulfur dioxide gas and acidified potassium dichromate. Okay, now this potassium dichromate is orange in color. Fine. Acidified means to the potassium dichromate a small amount of acid is added. It may be sulfuric acid or it may be hydrochloric acid. So this is complete term acidified potassium dichromate. Okay. So acidified potassium dichromate is, we have added a few mLs of sulfuric acid to potassium dichromate. Right. Now if I pass sulfur dioxide through this potassium dichromate, what is happening? The color is changing from orange to green. Now this is again predictable that your reaction has taken place. Okay, students. Now there are certain other features also which can tell you about the reaction. Now that is change in temperature. You must be knowing that in a chemical reaction, either the heat is lost or it requires energy to complete the reaction. When a chemical reaction produces heat, the temperature of reaction mixture rises, right? When heat energy is absorbed for a chemical reaction to proceed and form product, the temperature of reaction mixture decreases. Now what does this statement mean? Let's take the first statement. What it is saying, when a chemical reaction produces heat. So let's take an example here, students. When you mix lime in water, right? What happens? The container becomes warm. Lime is what? For just putting this temper on your wall, or that for whitewashing, this lime is used. Fine? Now when lime is mixed in water, the container becomes slightly hot if you touch it. Why is it so? Because the reaction between lime and water is producing heat. Okay? Now because of that heat, the temperature of the mixture is rising. Is it clear? So, now there are certain reactions which, now students, there are certain reactions which require energy. Now just imagine why energy would be required. I have told you, in a chemical reaction, what happens is the reactants are converted into products. The bonds between the atoms in the reactants is broken and the new bonds are formed. Fine. Now for the formation of these bonds, what is required is energy. Fine. Now how that energy can be given to the molecules? That can be provided either by heating it or by supplying electricity. Okay. Now these are the methods by which we can provide energy to a chemical reaction. Fine. Now in that case, if I am not supplying heat or if I am not giving electrical energy, from where that particular reaction is going to get that energy? From the environment. So if you touch that particular container or a conical flask or beaker, what you'll observe is that the temperature has been decreased. You'll observe that the walls of the beaker are cool. So, these are two types of reactions. Now, the reactions which produce heat are called as what? They are called as exothermic reactions. Now, this is exothermic. Exo. What does this exo mean? Exo, out. Therma means temperature and reactions. So these are exothermic reactions, and the reactions which proceed by taking heat from the surroundings are called as what, children? They are called as endothermic reactions. Endo, taking in, right? So these are exo and endothermic reactions. Now let's discuss few examples of these type of reactions. Here it is. Heat is evolved in a chemical reaction between quicklime and water to form slag lime. So the temperature of reaction mixture rises. I have discussed this example, okay? Now we have another example here. It is heat is absorbed in a chemical reaction between barium hydroxide and ammonium chloride to form barium chloride. So the temperature of the reaction mixture falls. Now I'll write this reaction in word form. Now what is it, students? It is barium hydroxide. barium hydroxide. Now this is reacting with what? This is reacting with ammonium chloride. Okay. Now what is this forming is? This is forming a new product that is barium chloride. Now one question can be there in the mind, that is, when the bond breaks, there is energy released. When a bond is formed, there is energy required, right? Now in an endothermic reaction, students, energy released is less than energy required. Okay, so when the energy released is less, so the energy required for formation of bond, from where you'll get, we have to provide it from outside. Okay, so this is an example of endothermic reaction. Is my point clear, students? Now there is another observable feature, that is change in state. We have already discussed what is state. State is that in what state a particular thing is, whether it is liquid or it is solid or a gas. Right? We discussed it in our previous sessions. Okay. Now take this example. The combustion reaction of a candle wax is characterized by change in state from solid to liquid and gas. Do you remember our session of physical and chemical change? There I told you, what I told you was that the wax present, wax is what? Wax contains your hydrocarbons. है ना? I'll write it here. No, I'll write it here. Wax contains your hydrocarbons. So this wax, that is solid, all of you know. This takes up energy. How? You are lighting up the candle. And this will break down into water and what? And carbon dioxide. So students, what is being done here? Here what is happening is wax solid is changing into water liquid and carbon dioxide gas. Got my point? So this is the example of change in state. Now I hope that these characteristic features are clear to you. Now let's move to chemical equations. Now students, as we were writing chemical equations, what we were doing is that we were writing the complete name of the compound plus the another compound, then an arrow, then the product. But you know, every time you can't write that complete name. In your chemistry, we have got different symbols or names for the compounds, for the elements. Okay, like your iron is called ferric, silver is called argentum, gold is called aurum. You must have done in this in your previous class. Right. Now there are symbols like for sodium you can use Na, for potassium you can use K, for lithium you can use Li, for calcium you can use Ca, for magnesium you can use Mg. Right? So there are different symbols for it. Now we can use the symbols for writing our equation. How? When we have got these small symbols, then why not using these symbols in the equation? Why to write that complete word equation? That is time consuming. Okay. So let's see how we can write a chemical equation, or what is a chemical equation. Chemical equation is the method of representing a chemical reaction with the help of symbols and formulae of the substances involved in it. Okay? So, what are the substances involved? They are the reactants and the products. Fine. The reactants are chemical compounds. They are all having their symbols, and you can write their formula also. Okay. So, now you can use those symbols and formulae. Now, how to relate a reactant and a product? Now, the reactant and the product can be related by putting an arrow in between. Now, the arrow head points towards the products and its tail points towards the reactants. So, an arrow pointing towards products indicates the substances on the left side are combining to give substance on the right hand side. What does this mean? What are the substances on the left hand side? We have discussed the examples of various reactions. Like I have just now, or let's take another example that zinc is reacting with sulfuric acid and giving what? Zinc sulfate and water. Now students, what are the substances on the left hand side? This is zinc and sulfuric acid. What are the substances on the right hand side? Zinc sulfate and water. So what we can do here is, we can just put an arrow in between. So if we are putting this arrow, what does this arrow indicate? This arrow, I'll make a good arrow here. Now what does arrow indicate, students? This arrow indicates that your zinc sulfate is combining, zinc is combining with sulfuric acid, giving zinc sulfate. Fine. So this is a relationship between reactants, the products. Fine. So this is how a chemical equation is represented. Not this way. This is the word equation. Now what are we going to do? We will put certain symbols, some formulas, and then we will represent a chemical equation. Now before dealing with chemical equation, you just tell me what is a chemical formula. You would have done in your 9th standard, or how a formula is written. I'll just discuss some things about it. Chemical formula, what is it? The chemical formula of a substance is the symbolic representation of the actual number of atoms present in one molecule of that substance. Now let's just break this huge sentence, right? Symbolic representation. So let's take an example. What example we are going to take? Let's take example of sodium chloride, the simplest molecule, right? Sodium chloride. Now students, you tell, what is the formula? What is the symbol of sodium? Sodium, the symbol is Na. What is the symbol of chloride? Just tell me, what is the symbol of chloride? Chloride is Cl. Now you must be knowing how we write the formula. We write the formula with the help of valencies, right? So what is the valency of sodium? Now before telling, I tell you valency, you just think over what is a valency. What is this term, new term valency? Valency is the number of electrons participating in a reaction, or the number of electrons required to form the product. Okay. Now this sodium has got the valency 1. Okay. So what is the valency of sodium? It is +1. What do you mean by +1? +1 is that it can lose 1 electron. And what is the valency of chloride? It is -1. That is, your chloride can gain 1 electron. So students, here sodium is losing 1 electron, chloride is gaining 1 electron. Now what will be the formula of sodium chloride? Sodium chloride formula, just guess. It is NaCl. Now this is the way how chemical formulas are written. So students, in this session we discussed about the features of chemical reaction and how to write a chemical equation and chemical formula. In our next session, I'll discuss few more formulae with you so that you can write chemical formula, fine, and write your own equations. And of course, we need a balanced chemical equation. So you should know how to balance a chemical equation. We'll try to discuss that also. Okay?